start with doing Agile and go to being Agile. And Ekipa itself is where the entrepreneurs thrive, entrepreneurs driven to change the way people think, work, and act. We also believe today's value creation is about breaking the rule on the game. And Ekipa has three cultures, which is think like an entrepreneur, work as an independent organization, and a balanced workplace. So the entrepreneur spirit is fixing stuff and making the world a better place with self-managed or self-organizations. Means all occupants set how they can work to achieve high quality standard and making impact. With all of those, we believe that we can create a balanced workplace and focus on the value to everyone. And for you guys that interest with the Agile Circle most, you can follow Agile Circle Indonesia by scan the barcode, or you can easy click the link that Revi shared on the chat box, Agile Circle Indonesia social media. Please hit that link and then just follow one of the or all of our social media so you will not miss our next event. And then we also share that on the Ekipa's website. It's on the Ekipa's event page. You can click the link that Revi shared, and then you can see, maybe you can find something interesting that you want to attend. And also we share a free ebook to some of you or to all of you that interest with Agile. So this book will help you to guide how we can start with Agile. And then you also can download that book by scan the QR or easily click the link on the chat box. Another one, we have another free ebook, Scaling Up. If you are working in the company that already implement Agile or Sustain and you want to scaling up your company to much bigger and more clients, you can start with this book. And then you can contact Ekipa if you have more information. All right, I think that's for the introduction from me and also Ekipa. Let's go to our main course today. So this is the background speaker, Roar Flemings. So just a little bit highlight. He is a founder for, he is a chief product officer for Redback Software and already working with software engineering for 24 years. 24 years, yeah. So without waiting for the ado, let me invite Roel to the stage. Hi, Roel.
Hi, Christian. Thank you.
Yep, cool. So if we see on the background speaker, we can see a lot of things that you already experienced. Could you share with us for the 24 years what you have been doing until this time, and maybe you can share about the Redback software?
Sure, yeah. So I'm originally from the Netherlands, and I graduated with a BTech in computer science from there. And before that, while I was doing my internship, I had saved some money and I had a chance to travel to India. Mm-hmm. So I found the country really interesting. So I was looking to work there for a little while. And I managed to meet this guy on the internet who gave me a job in his software company. So I came to India. And my plan was really to be here for a year, and then do some traveling and then just go back home and settle there. But then I met this girl here in India and I ended up marrying her. And now 20 something years later, I'm still here. That's how these things tend to go. That company I worked, we built a product, which was a workflow automation tool. And then I really enjoyed building our own product, rather than building software for other people. Mm-hmm. And then after some years there, I was looking for something new to do. And I had some friends in the United States who were investment managers. And then we decided to start Red Black, which is a company that makes software for investment advisors. And so that is how that happened.
So it's very interesting and long story. All right, then. So I think we can start the topic. So the stage is yours, Rolf.
Okay, thank you. Let me share my presentation here. Okay, can you all see this?
Yes.
All right, great. So I wanted to say in advance, thank you very much for giving me this opportunity to speak about building a secure software development lifecycle. I don't get a chance to do these presentations very often, so it's also something new for me. So bear with me a little bit. Yeah, I'm really excited to be here. So the topics I want to cover today, a little bit about terminology, just so to make sure we're all on the same page when I throw around certain terms. I'll give you a little bit of background of how my company Red Black got involved in this secure development. And then I'll outline the goals I have for this presentation, explain you how security and Agile can work together. And the heart of the presentation is a series of secure development practices. Now, I'll say in advance, I may not be able to cover all of them because there's quite a lot to it, and we have really only 45 minutes. But I'll share the deck with you and and my contact info. So if I can help you with anything after that, also very happy to do that. And then there will be 15 minutes in which you can ask me a lot of questions, and I'll try my best to answer those. So to start with the terminology, when we talk about a software development lifecycle, some people say, well, if you're Agile, you don't have a software development lifecycle, but that's not entirely true because the software development lifecycle just says, how do you go about building software from the point where you get requirements from the business to, all the way to running that software in production. And even if you're doing Agile, then your software development lifecycle is Agile. You may be doing product backlog groomings and you have sprints, and maybe you collect the output of all those sprints into a release, or maybe you do continuous deployment where you immediately release what you built, but you still have a software development lifecycle. You'll still do support and maintenance, etc. So when I talk about SDLC, that's what I mean. It's how do you, in your company, go about building and releasing software, and it will be different for every company and every team. It is different in my company than it will be in your company, than it will be in somebody else's company, because we all have different objectives and different ways to go about creating software. When you're talking about a secure SDLC, that means that at every step of your software development lifecycle, you can try to consider the security aspects of that. So right from the design of a feature all the way to running software in production, you try to consider and think about security. Now, this is an Agile group, so I don't think I have to explain you what a user story is, right? A small product increment that you can independently test and release. Epic, at my company, Red Black, when we talk about Epic, it's essentially a feature. So it's a collection of user stories that make up a feature in the product that you could talk to about a customer saying, hey, we have this new feature. So that's what we mean by Epic. Sprint, the time box period during which the team completes an amount of user stories. I'm sure you're all doing sprints if you're doing Agile. And finally, a release to us is the delivery of a set of completed epics. Now, if you're advanced and you're doing continuous deployment, you may not really have a concept of release because you just release an epic as soon as it's ready. At Red Black, due to the nature of our software, since it's investment and it's high risk and mission critical, we collect all of our epics and we do regular releases. So when I talk about a release, it's basically we take a set of epics and we ship that to the customers. Now, to give you a little bit of background, our company was acquired by Invesco in 2019, and Invesco is a very big asset manager, and financial companies, they are very good at one thing, and that is doing due diligence. So they put us through a very exhaustive and in-depth due diligence. And one of the aspects of that was that they came to our India office and they had hired a consultancy team to look at how do we go about building our software. And that went very in depth from, basic talks about, okay, do you use Agile? How do you do it? All the way down to looking at some of our source code. And I'm very lucky that I have a very good team here. So we actually did really well in this due diligence, except for one aspect, which was the security practices during development. And at that time in 2019, our main product was a Windows-based product. Our cloud version was in beta at the time, which was one of the reasons we kind of got away with not having these good security practices, because since we hadn't released the cloud version and the Windows version ran in the client's network, which was then the client's responsibility for security, we kind of got away with it because they thought, okay, once your cloud goes to release, you can fix these issues in the meantime. But for us, it was a big learning because some of the things that came up, we had never really thought about. And so it was a learning for us, and we found it, in fact, very interesting. So then when they went away and the acquisition was done, my team and we did a lot of research to figure out, okay, what kind of security practices should we actually do during development and how do we do them? And what we decided on was what I call like a shift left approach. We figured that security, if you look at it right just before maybe you're releasing the software, and then you find out all kinds of issues, it would then create a lot of delays in your commitments to customers. You may have to redesign a large part of the software, which, as you know, is very expensive when you have already written all the code. So we wanted to make sure we would address any security issues very early in the process. And we wanted to create a process that was not only compliant with what our clients are asking, but it was also meaningful to us. So not doing process for the sake of process, but doing something because it actually added value. And finally, we want to make sure it's viable because we are running 2-week sprints. And if you see some of the security practices, for example, the Microsoft SDL, if you do all of these activities every sprint, you will never have any time left to actually write any code because all these processes will take up all the time. So it also had to be something that would fit in an agile process. So my goal for this presentation is kind of to tell you what we have found and learned and give you some ideas of things you could think about. And I will focus that only on the activities you do during software development. So this presentation is not about infrastructure security. So I'm not going to say, okay, you need to have a firewall, and if you're running on AWS, you should implement security guard, and you should have hardened images and all that kind of thing. That's, to me, infrastructure. This is about software development, and during software development, so when you're writing code and testing, what kind of security activities should you ideally be doing? And the second thing I want to say is that, again, the SDLC is different for us than it will be for you. And a secure SDLC is also going to be different for us than it will be for you. So what I can do is I can give you some ideas, and then you will have to do your own homework on that and see if you're not doing, considering security aspects currently, how you would want to implement that in a way that works for you. So I'm not going to prescribe you and give you like a recipe, okay, this is all you have to do, because some of the things may not make sense to you. They may not at all apply to you, but I'll try to give you some ideas and some of the learnings, and then hopefully that will help you put together your own secure SDLC. So security and Agile, if you're still on the call, probably you are now realize that security is, and agree with that security is something that we must be considering. And at the same time, we've also kind of said that it may not be feasible to consider all aspects of security in every sprint, because we would never have any time left to actually produce some software. So the key to this is you should define what practices you want to be performing when. So there may be some one-time practices, which means, your team will just sit down one day and decide, okay, these are kind of the things that we want to do. And you define that once, and maybe you revisit it every year to make sure it's still valid. There will be a set of practices that you would want to do for every epic, or meaning every new feature that you're building. There'll be some practices that you should do for every user story, some practices for every sprint, some practices for every release, and some practices are kind of ongoing during the year. So if you do it like that, you decide which practice is applicable to which kind of routine thing that you're doing. Then you can also make sure it's viable so that you actually have the time to do these things and you're not doing too much of it and also not too little. And again, for you, this may be different because, again, if you're doing continuous deployment, you may not really have releases, so you would not have release practices. And you may have some other activities that you periodically do for which you may think, okay, I could do some security practices here. So again, I'm giving you an idea in these type of events, what practices you can do, and you have to see how you can apply that for yourself. So one-time practices are, you can establish some quality gates, and I'll get into what all these things mean. So don't worry too much if it doesn't mean too much for you right now. And creating an incident response plan. Epic practices could be defining security requirements, doing risk assessments on security and privacy, performing attack surface analysis, doing threat modeling, fuzz and penetration testing, and doing a final security review for every epic. And then at the user story level, practices are to use approved tools, perform code analysis, and perform code review. At the release level, creating a release plan and certifying and archiving your releases. And then for every sprint, to do a deep static code analysis and doing software composition analysis. And ongoing security training, third-party penetration tests, executing on your incident response plan, and updating your runbooks. So these are, I think it's 19 different practices that you can perform at these type of stages. So I may not be able to go through all of them in this presentation because it's quite a lot of material, but I'll focus on the epic, the user story, and the sprint practices, and we'll just see, how far we get. And if we can't finish it all, then maybe you can ask Ekipa to set to another session for me, and we can do a part 2 on this. Let's see. So let's talk about quality gates first. So quality gates is a one-time practice. What quality gate really means is that if you say, okay, these are some of the things we have to do, like code reviews, how do you make sure that that actually also happens? So that's called a quality gate, ensuring that you don't get past the gate unless you have performed these activities. So I'll give you some examples of quality gates that we have. For example, we use Jira, and in Jira, you can create subtasks against user stories. So we have a rule in the company that whenever you find a bug, you need to report that against the user story as a subtask. And what we've said, if the bug is related to security, you should make it a blocking subtask. When you do that, it means that in Jira, the user story can't be completed unless that subtask is completed. So that becomes like a quality gate, because also we cannot complete an epic unless all the user stories are completed. So this kind of forces us to always fix security-related bugs. And that's a quality gate. Another quality gate we have is that we say, okay, in Visual Studio that we use, and in Eclipse for Java, you have the same. There are analyzers that will analyze your code for all kinds of standards for security issues. So we have set up a rule that says, if the code doesn't pass the automated code analysis, then we fail the CI build. So when you fail the CI build, you can't merge the code. So again, you can never get code into production that hasn't passed the code analysis because you simply won't be able to merge it. So that's a quality gate. We do the same for unit tests. If the unit tests are failing, we fail the CI build, so you can't merge the code. And in Git, there's a concept of protected branches. So in our company, there's only a set of people like senior developers that have the right to merge code into protected branches. And we only release from protected branches. So if your code hasn't been reviewed by a senior developer and that merge request has been approved, you can never merge your code into a protected branch, and it can never get released. So that's another quality gate. Only code that has been reviewed by senior developers with merge rights can be merged into the main lines. And finally, we allow you only the promotion and the release of code when all the features, meaning all the epics in Jira, are in the done state. So that comes back again to that first thing about the user story. If there was a user story with a security related bug, it will be blocking. So the user story can't be completed, which means the epic can't be completed, which means the epic can't be released. So these are some of the quality gates we have established. And again, you can look at your own process and figure out, okay, you know, when it comes to security, we feel that these are must-have things. They have to be done. And then try to figure out an automated way that prevent people from ever getting past that without having done these things. So that's the first practice. The second practice, I'm going to be a little short on this because this could be an entire 45-minute session on its own. It's about creating an incident response plan. So if you get an incident in your software, let's say you're running something in AWS in the cloud, and one fine day a client calls up and you're a multi-tenant software. So you have a multi-tenant database with data from different clients. So let's say a client calls up one day and says, hey, I'm looking at my customer accounts and I'm seeing a bunch of accounts that doesn't seem to belong to me, which means you have cross-tenant data leakage, which is a serious security incident. You don't want to figure out when that client calls, how are you going to deal with that? You want to have that defined upfront very clearly. So the incident response plan is really about defining what is really an incident and what are the severity levels of the different types of incidents and how quickly are you going to respond to that. So those are your service level agreements. So for example, in Red Black, if a client calls up and says we cannot place trades, we have committed in contract that we will resolve that on the same day. So our service level agreement is saying that this is severity level 1, and we need to turn around that in a day. Then you can look at the sources of your incidents. It could be a customer calling. You may have an intrusion protection software running that raises incidents if it feels there might be an intrusion. And like that, you could have different sources. And how does the incident get created and where? And who's going to respond to that? And when are these people available? How are they getting notified? What happens if they don't respond? How do you escalate? And finally, how do you resolve the incident? So the incident response plan defines all these things very clearly. And there are tools that can help you automate all this, like PagerDuty, OpsGenie. So I won't get too much more detail into this because, like I said, this in itself is a whole topic, but it's important to define upfront how you're going to deal with security incidents. And now we get to epic practices. So these are things that you should be doing every time you work on a new epic or a new feature. And one of those is defining security and privacy requirements. And you want to do that at feature design time. Because when you define it at feature design, you do it before you write any code, and it will save you a lot of rework afterwards. So there's an organization called the Open Software Architecture Organization, and they have defined 4 types of security requirements. One is secure functional requirements. Then there are functional security requirements, non-functional security requirements, and secure development requirements. So this kind of seems like a funny wordplay, all sort of the same thing, but they all mean something different. And I'll take you through the slides to kind of try to explain you what all these things really mean. The first one is secure functional requirements. So what that means, if you're building a feature, right, you will have some sort of a functional requirement, whether that's a separate document that you then decompose into user stories, or maybe it's the user stories themselves. But at some point, you're going to build a new feature. So when you have secure functional requirements, that means every time you build a new feature, you also give some thought to what about security. And an example there is, what are the permissions required to use the feature? So let's say you have a user story that says, as a user, I want to be able to delete a customer from my system. So then the security aspect of that is who actually has that permission to do that. So like that, for every feature, you should think, okay, from a security and a permission perspective, is there anything I need to think about here? So what we've done at Red Black, it's very simple. We have a template for user stories. And in that template, we have put a section called security. That's really all we've done for this. But whenever the product owner is working on a new user story, and whenever he's grooming it with the team, everybody will give some thought to say, hey, is there any security aspects to this? And many times there isn't, and we just say not applicable, or we just remove the header. But it kind of forces us every time to think, hey, is there anything related to security? And what used to happen to us in the past is when we used to maybe release it to the stakeholders, and then they would bring it up and say, yeah, but we don't want everybody to do this. How are we going to segregate these permissions? And we'd be like, well, we never thought about that. Then we got to go back. We have to recode this. We have to retest it. So a lot of work lost. But now we kind of get reminded every time. So that's secure functional requirements. Now, there's also the functional security requirements. So that means if you're building a feature and that feature itself is related to security, like for example, a login screen or like forgot password functionality, now you have requirements that are about security. So how do you do that? Well, these you treat really like any functional specification or epic description or user story, however you define the specifications of a feature, you describe the specifications of that security feature and what all should be thought about that. So I hope, the difference is kind of understandable. Secure functional requirements is like you have a feature, what are the security aspects of that feature? And functional security requirements are how should security features work? Then there are non-functional security requirements. So these are architectural requirements of a feature. It really doesn't have much to do with the end user. So it's not as a user, I want to click on this button or, achieve this type of thing by doing these actions. It's more about the architecture. So you're thinking about stuff like, how is it going to scale if I have so many users? And how is it going to scale if I have this many users? And observability is an example. How can I monitor the system and make sure that I know what's going on and I can find problems before the customers start calling me? So one thing that's very important here, and that's why they're called non-functional security requirements, is that if you don't address these things, they become a security vulnerability. And that's something that we kind of realized only later, is that if your system doesn't scale, right, what is going to happen? It probably runs out of memory, for example. Once a server runs out of memory, its behavior becomes very unpredictable. If it's unpredictable, it could be exploited. So not addressing non-functional requirements basically creates security vulnerabilities. It also creates a lot of other problems, like in the sense that when you started with the feature, you had 100 clients and it worked flawlessly. And then one day you became successful and you had 10,000 clients and everything fell apart because it didn't scale. That's also an issue. So these things are like really important to always think about during development. So what we've done for that is we've defined a template called a non-functional requirements template. And the team has to go through this template for every feature. And they have to consider things like availability, extensibility, performance, robustness, maintainability, usability, scalability. And what we found is it's, again, a very simple thing. It's just a template that we have on Confluence. But because we have the template, we get those discussions at design time saying, hey, how is it going to perform? How are we going to observe it? How are we going to support it? And because all these discussions now come up front, we solve for that at design time. And it's easy to solve things at design time. It's very hard and costly to dissolve things once you have already released the software. I'm sure you all know that. So, you'll often find that simple reminders like this make a world of difference in the quality of the software that you ultimately will turn out. And then the final one here is secure development requirements. So these are development practices that avoid you creating vulnerabilities to begin with. And there's three main areas for that: secure coding guidelines, secure coding standards, and data classification. So we'll take a quick look at each of those three. The secure coding guidelines is something that we have adapted from the CERT, Secure Coding Practices, which is another organization that deals with security. And they have quite a list of items. You should be validating all your user input, for example, and all input from other sources. You should set your compiler warnings to the highest level and always make sure you resolve all those warnings. You should do static code analysis. You should architect and design for security policies so that it's easy and repeatable and in a very well-defined way how you enforce like user permission in your application. They say you should keep it simple because if you make software too complex, it is easy to introduce vulnerabilities and hard to find them. Another one, for example, is default deny. So an example here is that, let's say you have permissions for a user in your application. Now, what happens if you add a new user? You could say that by default, that user has all the permissions, and then an administrator could go in and deny what he doesn't want them to have access to. But the secure way would be whenever you add a new user, he has no permissions at all, and you grant him whatever permissions he should be having. So that if you accidentally forget to configure the permissions, it's better if he can't do anything at all than if he can do everything, including the things he shouldn't be doing. And then there's the principle of least privilege. And a simple example of that is if you say use a database like SQL Server, you could connect to that database using the system administrator account. It's easy, you have access to everything. But you also give users access to a lot of things they shouldn't be doing. For example, if you connect using that account, you can delete tables from the database. Most likely the users of your software should not have permission to do that kind of thing. So whenever you design software and services, you should always say, okay, how can I give users the least amount of privileges and still allow them to do what it is that they want to do, rather than let's just give them everything. And then there's something about sanitizing data you send to other systems. A simple example of that is when you do SQL queries, we all know about SQL injection attacks, right? So parameterize your SQL queries. When you're writing stuff to log files, make sure you don't write sensitive customer data like social security numbers, credit card numbers that should never go to a log. So you should have well-defined ways of sanitizing that. There's something called defense in depth. So maybe when you have user permission in the UI, you're checking that, hey, does this guy have delete permission? If not, I'm not showing the delete button to him. But then if you also have an API, you should again do the check there, because otherwise they could call your API directly. That check is not there. Now they can do delete even though they don't have permission. And you may want another check like that somewhere in your business logic, so that if somehow a mistake is made, or somebody manages to get past your first level defense, there is a second and a third level that protects you. Effective quality assurance techniques. So at Red Black, everything that's related to user permissions and other types of securities, we have automated tests for that, which run every release. So we're always sure that we didn't accidentally break or remove a security or permission related item that would automatically get caught by the tests. And then you should create a secure coding standard, and I'll get back to that in a next slide. And keep your credentials safe. So if you're using any credentials, say to connect to third-party systems, don't ever hard code those in the source code. Use a secure key store or store them at least securely in the database. So these are some of the guidelines. And again, in your case, you may have different guidelines. Some of these guidelines may not even apply to you. So the important thing is to create your own set of guidelines and then teach your developers and especially your code reviewers to be very aware of these and enforce them. And secure coding standards, for that we looked at OWASP. I've given you references at the end of this deck, so you can go look at these links. OWASP has a whole series of areas of writing code that you should consider when you think about security. Things like input validation, access control, cryptographic practices, error handling. So what we've done is we've kind of gone through this whole list and we've looked at each of these items and their guidelines and figured out, okay, now what is applicable to us? Like there's a lot of things in there that if you use, say, a modern JavaScript framework, that framework takes care of all of these things already. So we don't need to tell the developers to do this because the developers use the framework takes care of it. So some of the things like, for example, for access control, our secure coding standard will say, okay, whenever you have an API method that you're implementing, there should be a check there that says, is the user logged on? For that, we have a standard method. That's a method I'm showing there, and you have to call this. So that's a coding standard for our developers. Would not make much sense to your developers, but for ours, that is there. So you would have to design your own for these. For error handling, we have something like, okay, don't go write your own logging. You should use our standard logging class, and this is where that is. And if you're uploading files, even though the file may be named as .doc or .xls, you should be checking whether the file is not actually an exe or something that is renamed like that. And for that also, we have a standard method. So these are coding standards. It's very easy when we get a new developer on board. We can show them the document, they can go through that, and our code reviewers are very aware of it. So when they do their code reviews, they will be checking for all of these things. And then finally, there is data classification, which means it's especially important if, like us, you're in financial services or you're in healthcare or any other type of software where you use personal data of people, credit card numbers. So it's important to define all these types of data that you have, so that you can then base other standards on that. So for example, we have a type of data that's called restricted PII, which is sensitive personal identifiable information that when it's compromised, it could be used in a crime. So examples of that are social security number, tax identification number, passport number, credit card number. We also have something called linked PII. So that's a personal detail that you can use to identify a person. You may not be able to, steal his identity, but it's still something about that person, like his full name or his address or his email. And like that, we have different sets of information. So for basically every field we have in our database, it is defined what type of data it is, which also means if we're building new features that deal with some of that data, we can then say, okay, if it's restricted PII, you need to do X, Y, and Z. If it's only linked PII, you don't have to do X, but you still have to do Y and Z. So defining this for your software and your company, it's a very important thing to do. And then we have performing security and privacy risk assessments. So for every new feature that we build, you should do a security risk assessment, which we do by taking the technical design and then going through a security checklist to make sure all the aspects are covered. And secondly, we do a privacy risk assessment, where we're basically saying, okay, is there a privacy impact to this, which is related to that table I just showed you. For example, if we're storing some new restricted PII, so like say a social security number or a credit card number, that's considered a high privacy risk. And in our company, it being financial, we actually have to go to the privacy team and kind of tell them about why we are doing that and how we are doing it, and then get permission from them to be allowed to do that. So we have defined these different levels. Again, you would have to define this for your company, what makes sense, and then how you deal with that. And then a sample of the assessment checklist. I won't go through each and every item here, but this is basically the team will sit with the architects, and the architects are asking the team, does your design specify adequate controls for the specified data classifications? For example, if you're dealing with credit card numbers, do you have protected that, and how have you done that? And they will ask the team, okay, does your design adhere to the principle of least privilege? And so many other questions. So by going through all these questions, there's a lot of dialogue, and it forces the team to kind of think about all these different security aspects for that feature. And again, it prevents us from having to do a lot of rework after the fact. So you could take a look at this list and then, determine on your software, what are some of the things you should be assessing. Okay, and then, so there's a practice called attack surface analysis, which is, it's about reducing the opportunity for exploits. So if you're exposing your software out on the cloud, right, it's potentially accessible to the public. The more the more service you expose, so the more services, like, let's say, simple example, like FTP and HTTP, and the more ports you have open, and the more things you expose, the more risk is there, right? It gives an attacker more areas that he can try to exploit. So you should always be looking at, do I need all of this? And if I don't need it, let me get rid of it. If you have old APIs that you're no longer using, don't just let them sit there, because again, it increases the risk. So remove those. And again, apply that principle of least privilege. So don't give users permission for doing things that they don't need to do what you intend them to do, and have those layered defenses. So ideally, every time you introduce a new service, a new component, a new interface that is publicly exposed, or you create a new API, or you update an API, or you make something obsolete, you should redo this attack surface analysis to see, is there anything that I can now remove so that it's no longer exposed, so it no longer poses a risk to me. And closely related to that is something called threat modeling. So you may have heard of threat modeling. It's another thing that could be like a 45-minute topic easily. When you do threat modeling, what you basically do is you say, hey, I've built this feature or this service. And now in its operational environment, so, I'm hosting it on AWS, it's sitting there in a container, I have some front end for it, I have API gateway. Now in that whole context, what about security there? So it's a bit of a team exercise. You basically get your whole team in the room, and it's kind of a fun thing, because what you try to do is find ways to hack your own software. And there's a methodology for that called STRIDE, which looks at all the different ways that you could threaten that software from the outside. So there are things like, okay, I could access your software and pretend I'm somebody else than you think I am, so that I get some permissions I shouldn't have. I could tamper the API requests. I could do with an iOS service attack. I could try to get elevation of privileges. So if you follow this STRIDE model, you will analyze all of these different threats to your software and make sure that you have an answer on how you deal with all these things. So it's a very interesting thing to do. It's also pretty complicated. So like I said, it's kind of a completely separate topic. You can get courses on this. If you're on Pluralsight, there's a lot of training around STRIDE and threat models. I would say definitely something you want to investigate if you're not already doing that. And again, you should do this every time you introduce a new service component or interface. Every time you pass sensitive or confidential information across trust boundaries, so from one system into another. And every time you change security service, such as your login screen or your authorization or your user permissioning, you should revisit that threat model to make sure that if you look at all those different areas, you have not created a security vulnerability. How am I doing on time here, Christian?
No worries, you still have time, like for 10 for 15 minutes.
Okay.
Yeah.
People haven't left yet.
People increase here, don't worry.
Right,
I think it's very informative. So yeah.
Still here,
Okay,
don't worry.
Yeah.
All right. Okay, so practice 7 is called fuzz and penetration testing. So fuzz testing means you're basically taking your APIs and you deliberately throw a lot of malformed or random data at it to see if you can break it or create issues. Penetration testing, that should be attack, not attach. But penetration testing is kind of like you kind of examine the system and you try to find ways to exploit vulnerabilities. These things are best done using tools. There's a tool from OWASP called Z-Attack Proxy, which it does both fuzz testing and penetration testing. It's also free, which is great. If you're using GitLab, the advanced versions have something called Pizfuzzer. There's Nmap, there's Metasploit. So there's different tools that you can point to your application in the cloud, and they run a whole set of tests, and they will tell you all the different vulnerabilities that they find. So that's a good thing to do every time you have a new feature that you're going to release. And then finally, at the end of the epic, you should ensure that you've done all those things that I just told you, right? You did the assessments, you did the attack surface analysis, you did the threat modeling if required, and you did the fuzz and penetration testing. And again, you don't have to do this for every epic. You have to consider whether it should be done. Because, for example, if I'm just making some changes to the UI, or I'm adding some sort of business logic feature that hasn't really changed any APIs, hasn't really touched anything related to security, I don't have to go do a whole attack surface analysis or do a threat model, because all I've done is basically added a few UIs. The important thing is that the team takes a moment with the architects and says, hey, is any of this applicable? And often what happens, I would say for us, maybe 8 out of 10 features, it's like not applicable, not applicable, not applicable. But we did sit and, took some time to think about it. And especially that security checklist, it often brings up things maybe not directly related to security, but related to other things that we really should be having a look at. So it always adds some value, but we don't do these things just for the sake of doing them. If we feel it's not applicable, we just say not applicable and we skip it. So it's like a 10-second exercise. And if you can, automate this. So what we do is, once the architecture team decides that, yes, you need to make a threat model of this, they will create a blocking issue against the epic in Jira. So that means for us that epic can never be released unless that blocking issue has been marked as done, which means the threat model was done. So it becomes a bit like a quality gate. And now we go on to practices that you should do every user story. So there's 3 of them: defining a list of approved tools, defining the mandatory. Oh, sorry, okay. So this is a user story practice, and that practice is the use of approved tools. So it basically means that you should formally define the list of tools that your developers can use. So it could be very simple. It could just say, okay, it's Visual Studio, it's DevExpress for the UI components, and it's SQL Server for the database. But at least you have it formally defined. And then in Visual Studio, there might be certain security settings that you can enable, that help you develop secure code. So you should define what these are. These settings should be enabled for all developers. And then ensure that these are followed. Some of it you can check into Git. So, when the developers check out your solution, automatically these settings will be applied so they can't forget. But you have to find a way to ensure your developers only use approved tools. And this is one of those things that we see come up when we get a new prospect. We get these long questionnaires and asking about how we deal with security in cloud. And this is often a question that comes up. Do your developers use only approved tools, and how do you guarantee that? And then we say, yes, we do. And we can share the page from Confluence that lists those tools, and then it satisfies that concern. Another practice is to do code analysis. So we already talked about that a little bit. Both Visual Studio as well as Eclipse have these inbuilt analyzer tools that you can configure to check your source code for all kinds of things. You want to make sure that you enable all of the security policies. Like the Visual Studio analyzers have some 30 or 40 rules related to security. Enable all of those and make sure you break the build and break the CI build if somebody tries to check in code that has errors against those policies. Which again means if the CI build breaks, nobody can ever merge that into the protected branch. You can never accidentally release code that has potential vulnerabilities in it. And then there's a manual code review. And we talked about that a little bit too. We have we force a manual review of all the code before it can be merged in a protected branch. And only our developers with merge rights have that means to do so, and we release only from protected branches. So I think this whole SDL, it kind of depends how big of a team you have, right? For us, it's easy now. We have a backing of a large firm, so cost is not really an issue. We can buy tools. We also have a lot of staff. If you're a 5-person startup, obviously you can't do all of these things. But I would say if you can just do one thing, that is, if you're using source control, set up a protected branch and have your senior developers review the code that goes in. We didn't do this in the beginning because we thought it wasn't that important. We didn't have that much stuff. And I'll tell you, I still come across code that was done in those days, and it sits there and we don't have the time to clean it up, and it creates a lot of issues for us. So if there is one thing that you can take away from this entire presentation, use protected branches, appoint some developers, and always have the code reviewed. Even if they only review each other's code, this review will add so much value in terms of, you know, the cleanliness of your code base. It's not only a security thing. It also helps you have a code base that is clean and easy to maintain. And then we have sprint practices. So these practices we do at the end of every sprint or during the sprint. And one of them is called deep static code analysis. So that's a bit different from those code analyzers you get with Visual Studio or Eclipse, because they kind of check in real time. What a real SaaS tool does is it kind of creates a whole model of your application, and then it analyzes all the different execution paths, how data gets passed through all your methods and layers. And from that, it detects security flaws. So it's really advanced. It also takes, for us, it takes almost a day to run it. So it's not that you can do this on every check-in. And what we used to do is we used to run this before the release, but then we found out sometimes a lot of issues came up, and then it got very tight to fix those just before the release. And it also added risk because all of our testing was already done. So now we run it once a week over the weekend. And then when we come in, we look at the issues. And if they're small, we pick it up in the sprint itself. If they're bigger, we schedule it for the next sprint. Tools that do this are Veracode, SonarQube, Ment, and Vortify. Veracode is probably the cheapest, but they all cost quite a bit of money. Now, the good thing is, if your company is a bit bigger and they have money, if you ask for tools and you say they're related to security, management is typically very keen on honoring that. Because if a security incident happens and you would say, well, we asked for the tools, but this manager didn't give it to us, it may be a bit of a problem for him. So always when you want these type of tools, if you can somehow link it to security and you're in that kind of company, you have a much bigger chance of getting the money to buy them. And we use Veracode. I feel it's very good, very advanced. It finds a lot of issues. So if you have the budget for that, highly recommend it. And then, like I said, we try to fix the flaws then in the next sprint. And sometimes there may be issues that are false positives. They're not really an issue, or they're by design, or they don't apply to us. For that, the developers have to put in a justification. And then we have a certain management level that approves that. So that's how we mitigate non-issues. You obviously don't want your developers to be able to make those decisions independently. There always should be a level of approval there. And then another important thing is called software composition analysis. So that also needs a tool, and this is all about open source. So if you're like us, nowadays we use a lot of open source. Sometimes we don't even know our developers are using open source, because there's this thing like in Visual Studio, this thing called NuGet, and you can just say add package, and now you're using a bunch of open source. But there is a risk to that, because not all open source is equal. And what if there is vulnerabilities in your open source libraries? Or what if, you know, you're using a very outdated version? And another issue with open source is the license compliance, because depending on the license of the open source, some of the licenses actually say if you use that open source, you are then mandated to make all your code open source, which if you're like us, you're selling a commercial application, that's not, you know, really what you want to do. But you may not be aware of it. And where it gets really tricky is that open source often uses other open source libraries that then again use other open source libraries. So there's a whole level of nesting here. And it's almost impossible for you manually to figure all that out. But there are these awesome tools now. The one we use is called Ment, which has a whole library of all the open source libraries that are available in the world. And it tracks vulnerabilities, it tracks the latest versions, and it tracks all the license compliance. And you can point it to your application, and it sort of investigates all of this. It even goes into the nested libraries, and it gives you a complete report where you may have problematic licenses, which one have vulnerabilities, which version you can upgrade to get rid of the vulnerabilities. it's really important. And one of the first things that this Invesco did when they came to look at our software arm was to run this tool on all of our software to make sure we weren't using some problematic libraries, especially from a license compliance. So when we saw that, we were like, wow, this is so cool. And then we added this tool to our arsenal of tools. Here also, what we do is, if issues come up, we try to fix those in the next sprint. Sometimes there are issues that we are not able to mitigate, or we feel they are not required to be mitigated, then we justify them, and there is again an approval level on that. Then I'll go over this a bit quick. This is a release practice. So every time you create a new release, what we do is we have a release plan, which has all the important dates related to that release. And there's kind of a checklist of all the things we should do to do a safe and a good release. Some examples of that: we prepare release notes. We make sure that we do some manual regression testing against not only the new features, but also some of the older ones. Along with all of the automated tests we have, we get sign-off from our product manager in the US. We create those final static code analysis reports. And there's also business things, like we tell the business that they need to update the pricing book for new billable modules. So it's like a whole list of things that should be done for every release. So that's an important thing. It's an easy checklist. This was one we just keep in Excel, so it's nothing sophisticated. But in the end, we have a record: who did what, when did they do it, did we forget anything, did we skip anything, why did we skip that? And it's stored that if later on something comes up, we have something to look back at. And then there's certifying and archiving your release, which means you want to make sure that all these things we talked about today have been done. Hopefully, a lot of that is automated. And you archive your release so that you can service it afterwards, like when you get support tickets, for example. So it means we archive all the reports on SharePoint. We fork a maintenance branch in Git so that we can do hot fixes against that if client reports issues. We archive our release notes on cloud. We archive our images and all the packages so that we always have an exact version of all the releases we've done. So that's certify and archive. And then finally, the ongoing practices, security training. So one of the things, if you build software for cloud, one question you're always going to get from clients that are concerned about security is, does your staff get security training? They don't really care what kind of training, as long as there's some sort of training that is called security training. So what we did, we took advantage of this because we all wanted to get Pluralsight subscriptions, because Pluralsight is so great for learning all kinds of cool tech stuff, but it's expensive. I think it's almost $500 a user. So what we did was we went to our management and said, listen, we need to do security training because our clients asked for it, and the best way to do it is Pluralsight. So then they got us all Pluralsight subscriptions. We do one training a year and we get access to all the other cool content. So it's, again, if you're in a larger company, try to leverage this security to get some other benefits along with it. Third-party penetration testing. That is where you go out and instead of trying yourself to find ways or vulnerabilities in your software, you go to a professional company that does this for a living. The good thing with that is you don't know what you don't know. If you use them and they're good, they often come up with issues that you've never thought about. It also gives you legitimacy. So when your clients ask, what do you do about security? And say, oh, we've got a third-party security penetration firm. They test our software twice a year for vulnerabilities. Typically, the clients are very happy and they tick off that box. Do use, though, a quality vendor. We had an earlier vendor who never found nothing. So we thought we were awesome. And then we exchanged them this year for a really good vendor. And they found a whole bunch of things. And we realized we were less awesome than we thought we were. And we learned a lot. And we fixed some, potential quality issues and security issues in our software. So do make sure you get what you pay for. Don't go for the cheapest vendor. Get somebody who does real quality work. What we do is, if these vendors find high priority issues, it's never happened till now, but then we resolve those immediately. And some of the other issues we schedule for future sprints or releases. Execute on your incident response plan. So every time a security issue does occur, run that incident response plan we talked about and do a post-mortem and a root cause analysis. So try to figure out, okay, why did this happen? What is the real underlying issue? And what can we do to make sure this never happens again? And that may mean some development changes that you then have to schedule in future sprints. Finally, update your runbooks, which means a runbook is about, hey, if some issue happens, what are the steps to resolve that? You need to continuously update these. So every time you have an incident or some other operational issue and you've learned something, update the runbook so that finally, no matter what happens, you have a predefined set of steps on how to deal with it, which trust me, will reduce your stress levels greatly when you really run into an issue. So those are the 16, I think I lied, it's only 16 practices and not 19. These are the 16 practices that we do. I hope some of those will resonate with you. And, you know, I was able to show you some things you could think about. Again, don't think you have to do all the 16, and definitely don't think you have to do it our way, because we do it one way and in a way that is applicable to us. I've given you some references. I'm sure Christian will share my deck with all of you. These are some links to some of these things I talked about, very helpful to read through and see how you can apply that to yourself. And this is my contact info. I hope what I told you today was interesting. Thank you again so much for allowing me to speak. I'm on WhatsApp, I'm on LinkedIn. This is my personal email. If you have questions, very happy to, you know, talk to you and share what we've learned and hopefully help you out with something. And that's all I have for today. We can take questions.
All right. Thank you all for the material. I think it's very informative. As many people said in the chat box, so mitigate risk, making a guideline and template, so it will be more documented very well, and then best practice and tools. And you have like 16 practice. I think it's very
yes.
to the point and very technical. Okay, cool. I believe 37, 36, 35 people in here will be have some question for you. So guys, please just unmute yourself and then speak if you have any question. I believe it's very interesting. Maybe you can consult with Roll about your company, what you have been doing in company. Is it correct, or maybe something that we can improve? You can improve. Question?
I have a question, if I may.
Yes, please.
Okay.
Was that the question?
My name is... yes, sorry. Hello. Okay. Hello, my name is Abdurrahman. I have a question about your experience. Before I want to give my thanks. This is a very valuable presentation. This very informative. And what I would like to know is from this 16th practice, do you have your own assessment, your own based on your experience? Which practice is most valuable, especially compared to the cost it uses? You said before, you mentioned preview, manual review, code review, but do you have other practice that you think very important and very valuable and worth the cost? That's from me. Thank you.
I mean, I think one thing that is very important is what I talked about, that open source analysis. Even if you don't have the money for the tool, you can at least try to look at it manually, at least the direct libraries, and see what kind of licenses are on those. Because some of the licenses, like I said, you could get into a lot of legal issues if it's one of those licenses that says if you use it, you have to open source your own software. And then if you don't do that, you know, potentially there could be legal ramifications of that. So I think that's a very important one. Let me just take a quick look at the list of all the practices and see which other ones. Yeah, and I think we talked about that defining security requirements, right? And I gave you kind of that non-functional requirements checklist. So to look at performance and scalability, observability, those type of requirements that are not related to user features, but more related to how you architect the software. Because to be honest, at Red Black initially, we weren't that concerned about performance, and a lot of things we didn't consider that. We just implemented the way we thought it was fine, and because we had smaller size clients, it also worked fine. But then when we moved to cloud especially, and we got larger clients, we ran into some really serious performance issues. And at that time, to go in and fix that, it's not always an easy fix. Sometimes you maybe tune an index or something in SQL Server and the problem goes away. But if it's more of an architectural issue, it could take you months to rewrite that. And it always comes at a time when you don't have any bandwidth to rewrite anything. So to have those conversations every time you make a feature, and have your team ask themselves, okay, how would this work if I have 100,000 of this? And how is this going to work if I have 100 clients doing this particular function at the same time? Just the discussions you get out of it will give so much of value and result in such a better implementation. And we've seen this in practice in the last few years that we've been doing that. The quality of our software has gone up exponentially just because we are having those conversations. Does that make sense?
It is very good points. Thank you very much.
Okay, you're welcome. Thank you for
Okay,
listening.
thank you. It's Mas Abdurrahman, right?
Yes.
Yeah, cool. I think the non-functional requirement also you can find it on PRD. Sometimes product owner we created it to mitigate the risk and something like that. I think I'm agree with Ro. It's very important. All right, then we can go to the next question, guys. Do you have any more question? Please just unmute.
Hello.
Yes, hello.
Okay, I have a question.
Yes, please.
First, thanks for the presentation. It's really valuable information. Regarding of my question it's regarding of the penetration testing. So there are some informations mentioning that some companies which have a deal with the quality vendor about which part should do the penetration testing. So it's like an artificial one instead of testing the whole part. How do you think about this?
Are you asking? I'm not sure what you're asking me.
Yeah. Actually, there are some informations mentioning that some companies which have a deal with the quality vendor about which part should do the penetration testing.
Yes.
So it is like an artificial one instead of testing the whole part. I don't know what is the concern about this, but how do you think about this?
I mean, they will actually test against your real environment. And then they give you a very in-depth report of all of the different findings they have. And there's also different types. So some focus on network, some actually look at your APIs. You can even give them access, say if you're on AWS, you can give them access to your AWS environment and they poke around inside it. So they have more ways of seeing what is wrong. I think it's very valuable, but it is expensive. Especially if you want to get a good vendor. So I would say if you have the budget for it, you should definitely do it. If you don't have the budget, you could use some of these tools like that OWASP Zap Attack Proxy to do some of this testing yourself. Does that answer your question?
Yeah, okay, that's good. Thank you.
Okay, thank you, Mardiansyah. All right, we can move on to the next question. Ligede?
Yeah.
I think you unmute. Okay, cool.
Yeah, I have one question.
Yep.
Okay, first, thank you, Ro, for the explanation. I think it's very valuable to us. Yeah.
Thank you.
My question is,
that.
compared to the traditional SDLC, what do you think is the duration of the development if we implement the secure development lifecycle compared with the non-secure development lifecycle?
It will kind of depend on what features you're building, because like I said, if like our software is about trading logic, right? If we're just adding some new trading logic, there's not going to be any changes to the security exposure. So most of these activities that I talked about would say non-applicable, and we can just skip over them. Of course, if we're building like an entirely new component that has a lot of new services and APIs, we would be doing a lot of these activities, and definitely it would take more time than if we don't do them. The question though is that for some, I feel in the long run, it saves you time, because if you discuss non-functional requirements up front, that discussion doesn't take too much time, right? If you write all the code and then you have to scrap it all and rewrite it again because it's not scaling, then eventually that will take you actually more time. So it's a bit hard to say. And that is also, I think, why you have to kind of look at the size of your team. If you have only a 5-person team, you may not be able to do all of these activities, and you may have to reduce the amount of things you do and design it in a way that works for you and still make sure you can turn out software at a certain velocity. So it's a bit difficult to say.
Yeah. Because sometimes we found the customers, they only realize about the security impact only after the end of the projects.
Yes.
Yeah, so I have some experience about this, and then we can then we have to go back again to the design. And
yes.
So that's why maybe we can during the requirement gathering, we talk to the customer about the security aspects first, so they will know how this will impact the projects overall.
Yes, exactly. And these discussions, they relatively take less time, right? If you're talking for an extra hour because you're covering some of these security requirements in the bigger scope of the project, that is not much.
Yeah.
But if the customer comes up afterwards and say, actually, we need different user roles with different permissions, and you haven't addressed that at all, now the whole project may get postponed by 3 months. They won't be happy with that either.
Yeah.
But it's a little easier if you're a product company and it's your own product. You can kind of control this. I know when you're doing like work for other companies, they may just say, we don't care about security, just get it done as fast as possible. And then you don't have much control.
Yeah. Okay. Thank you.
All right.
Thank you, Mas Gede. Yeah, the most important thing is we need know about the user expectation, like Rol said. If they doesn't care, then what we can do, right, Rol?
That's a challenge when you work for other people. Yes.
Yeah. All right. Cool. Thank you, Mas Gede. All right. Next question, guys.
Hello, Mas Christian.
Yes. Hello, Mas Sudik.
Hey, good evening. Hello, Rul.
Hi.
Thank you for the presentation. So I just have a small question here. There's a lot of things like you have explained about 16 practices. So do you have any like what to say, like the best practices, or maybe a rule of thumb? For example, if we want to apply that kind of practices in small projects, small teams, small company, but we want to get the maximum of the result of that practices. Maybe get like 5 or 7 from the 16 that you already mentioned, something like that. The prioritize it.
The top 5.
Yeah, something like that. Because I don't think in a small project we cannot. I don't think it's cost really big cost to apply all the practices. So
that's
maybe,
true. Absolutely.
Yeah.
Yes.
If that's the case, do you think is it possible to make like big 5 as you mentioned? Thank you.
I mean, I would say like you can definitely do the one-time practices because they're only once, right? So setting up your CI builds, for example, that it always runs the unit tests and fails the CI build when the tests are not passing, or configuring the code analyzers in Eclipse or Visual Studio. that's you do that one time and you can use it for all your projects. So I say definitely do that, because you don't have to repeat that. Then again, the manual code review, I would say the NFRs, the non-functional requirements, and just having that conversation about security at design time. So that little checklist that I have, modify that for what makes sense to you, and just have that conversation, because that doesn't take you much time and saves you a lot of time in the end. Maybe, the attack surface analysis, threat modeling, fuzz and penetration testing, it might not be viable for a small team. Again, the open source analysis, though, even if you don't have a tool, at least take a look at the libraries you use directly and make sure they use the right licenses so that you don't get, in a lawsuit at a later stage. What else? If you would just do all these, I think you'd already be in pretty good shape. And it's always better to do a little bit than nothing at all. Like, I don't want you to feel like, okay, this is too overwhelming, we're not going to do any of it. Even if you do just one, it will be a good thing.
Yeah, at least we understand where to start with. I mean, not all the practices, because it takes time, it takes a lot of effort and also big money for that.
Yes. So if we share you the deck, for example, and you look at that security assessment checklist and the non-functional requirements, those topics I had, like observability, scalability, performance, and you just sit with your team and you just go through my checklist and you say, hey, what do you guys think about this? How are we going to deal with single point of failure, for example? If my whole application goes down, do we need multi-region? And you just have these conversations. It may take you only an hour and a half. What will happen is that you'll find some of these items in my list that every time you feel it is not applicable, then you just get rid of it. And after a while, when your team gets into that mindset of thinking about security, they're probably going to bring up some other checklist items that may not be applicable to us, so they're not on our list. And you slowly get to refine that list. And that doesn't take a lot of effort, and it gives you a lot of value. So I feel those things, at least try to do these. I mean, we took almost 2.5 years to implement all of these things, and we had now, the backing of a big company, so money isn't really the issue. When we were independent, some of these, like third-party penetration tests, we may not have been able to do just because of budget.
Yeah.
Okay, is it answered your question, Masudin?
Yeah, got. Yeah,
all right.
That's really cool. Thank you for the answer.
Yeah, it's budget issue, but it depends on where you are. I mean, the company. I mean, status of the company. Are you want to scaling up, or you want to leverage, or you are start from small? I think CI/CD it's very important. If especially if you are working with more than 2 coders.
Yeah. Right. We already have that CI/CD.
All right, cool.
Yeah. Thank you, Christian.
Yes.
Yeah.
All right, so I think we can have one more question, and after that I will takeaways and closing this event, because I will share the feedback link so you guys can give the feedback. But after that, after I close this session, you can stay here and have some chat with Rolf. So don't worry. So this is the last question before we close the event, yeah. But the Zoom meeting will stay open. All right. Last question, guys. Maybe you guys want to consult what you're already working on. Yes, please.
Yeah. Hello, may I?
Yes.
Hello, Raul. Thanks
Hi.
for this amazing information about the security.
Oh, thank you so much.
I have a lot of questions about this, but maybe my top of the question is, does your team have a roadmap for studying security? Because in your practices on maybe 16, yeah, is security training.
Yes.
Yes. Do you have like a roadmap for studying security for your team? Something like that.
Yeah,
Yeah.
in fact, for us, this is kind of mandated by the parent company. So we actually get an email saying that, you know, it's time to do this training. And then if we don't complete it on time, they keep on reminding us. So it's very centralized. And then we take some of our own trainings from Pluralsight also. But publicly available, I would have to look for that, because the ones we use they're all like paid for training.
Yeah.
So yeah, sorry, I can't be more helpful that I don't have like a set of links that is like publicly available for going through this. You know, what I do find though is that a lot of this is kind of common sense. You know, the training, it's very difficult to make a security training other than what I'm doing now, just to give some ideas, because it is so different between all the different companies and the way they do things. So it tends to be very generic and does not add that much of value.
Yes, that's true.
You know, that's a bit of a challenge with that. But on Pluralsight, there are some good courses. I would say, like, if you want to do any training, try to find a threat modeling course, because the threat modeling, it's not only fun to do with your team, it also finds really good issues, and it really makes you think about security in many different ways. And I do believe I will do some research. I think there are some publicly available courses on that, because it's a very popular and widely used technique.
Okay, thank you for the answer.
So if okay, thank you, Mas Ridi, for the question. I think if it's not clear yet, you can ask Rol by via LinkedIn or WhatsApp, Rol. I think Rol can recommend
Yeah,
a good,
please
a
shoot
good
me an
course.
email.
Yeah, exactly. All right. Let me share my last slide, and then we can continue our Q&A. So guys, as I said before, this is our time box. Please share your feedback to us, to the speakers, and all, and to Ekipa. And maybe you have any thought or something like that, you can share. You can find the feedback link on the chat, I believe. Yeah, and then you can share some thought to us. All right. I think that's it for today. I will keep this meeting. So everyone, if you still have interest with this topic, you can stay. And for everyone that want to leave, please leave. And then have a good day, everyone. See ya.
Yeah, thanks everyone. Thank you so much for listening. That was fun.
Christian.
Thank you. Bye.
Bye.
Okay, any more question, guys? Whoever stay in this conversation?
Hello, Ro.
Yeah, sure, Mas Rindi, please go ahead.
Yeah, like I talked before, I have a lot of questions of this topic. About this, all these practices, should there be a person in charge in specifically, like maybe security engineer or something in your team?
Not like that. We have like a, you know, the company has like a chief security officer and a security team, but they deal more with infrastructure security. So like network monitoring and all that kind of thing. For development practices, it is really my architecture team that owns this.
So the